Hello, my name is Peter Goon, and hi, my name is Peter Goon, and today I'll be doing 3 LeetCode problems. Best time to buy and sell stocks, valid parentheses, and valid palindrome. Okay. You are given an array of prices where prices I is the price of a given stock on the ith day. You want to maximize your profit by choosing a single day to buy one stock and choosing a different day in the future to sell that stock. Return the maximum profit you can achieve from this transaction. If you cannot achieve any profit, return 0. And the first example, we have the input array. We have 7, 1, 5, 3, 6, 4, and the output is 5. So where did they get that? Okay, so they bought it at 1, and then they sold it at 6. Okay, and the second one, there's no output. There's no profit. Fuck, can't see the bottom. I can't even raise this shit to the top. What the fuck? Oh, there's nothing there. Okay. I think I've done this problem before. So I think the strategy was you wanna buy it on the low. You wanna buy the stock on the day with the lowest price, and then try to sell it after that. So I guess I'll start writing pseudocode. How many variables would we need? We would need one variable to store the profit. We would need another variable to store the current buy price. What other information would we need to store for this? Profit. Okay. So yeah, we wouldn't need to store the sell price because we would store the profit and we would just be able to calculate if it's better or not. Okay, so I would go through the array linearly. Let me try to draw out my thinking. So what's the example? 7, 1, 5, 3, 6, 4. 7, 1, 5, 3, 6, 4. So we would linearly go through the array because we need to visit every single element at least once. Sorry. Fuck, I got like 2 seeds. So let's start and just move this over here. X and Y, just for the demonstration. Right? X is profit, Y is buy price. So, okay, we're at 7, and profit is X, so it would be negative infinity, and buy price would be infinity so far. So we go here, and we can make this 0, not negative infinity, because then we wouldn't have to change it from negative infinity to 0 later. Okay, so we would, 7, we're here now. And then since 7 minus 1 is less than 0, or no, 7 minus nothing, yeah, we're just good. Wait, how would I do this at the start then? How do we calculate profit? We calculate profit by subtracting current buy price minus, it would be buy price minus, current buy price minus buy price, so it would be 7 minus 7 here, so it would just be 0, so it wouldn't change. And then we would go to the next one, and 1 is less than 7, so we could change that. And then here it would be 1 minus 7, which is negative 6, and it's still not bigger, so it would just stay the same. And then we would go here, 5. 5 is bigger than 1. We do 5 minus 1. That's what it would be current price minus buy price. Calc profit by current price minus buy price. And the profit here would be 4. And then go to the next one. It's not lower. Profit would be 2. We don't change it. Go to the next one. Profit would be 5. So we're good. And then, yeah, okay. I think I can write this in code now. Excuse me. So profit equals 0. Buy price equals, what would we say? Fuck. Right now. Starting at infinity. Yeah, that makes sense. Because we would want it to be like the highest possible value. How to get infinity in Python. Positive infinity float inf. Do I have to import? No, I don't have to import anything. Okay, it goes float inf. Shit. There's no, where the fuck is it? Sure. Is it here? Where is the Vim setting? Oh, debug code editor. What the fuck? There's no Vim setting? I swear there was. Or whatever. Okay. For price and prices. If price is less than buy price, price equals price. And then current profit is equal to I'm actually blanking right now. Current price minus buy price. Right. It's not clicking. What the fuck? Current profit would be current price minus buy. What would happen if you would subtract infinity from something? That would be a pretty big number. I feel like that's a bug because, price. Now it would be a small number because we'd be subtracting infinity. So no, we're good. I think we're good. Price minus buy price. If current profit is greater than profit profit is equal to current profit, return profit. Okay, let me go through this real quick. Profit is equal to 0, buy price is equal to infinity for price and prices. The price is less than buy price. We set that to be the buy price. We calculate current profit by subtracting current price by the buy price. Okay, so we're good here because like it'll always be less than infinity. And then it would just be like the same thing, it would just like default to 0 here, so we're good. Or yeah. And then if current profit is greater than profit, profit is equal to current profit. Return that, is it outside the loop? Okay, run. Okay. It beats 90. Oh, complexity. What is the runtime complexity for this? I think it's O of n because we just loop through the whole input array once, and we don't, yeah, that's all we do. And we just do some things to it in here. So it would be an O of n time complexity. Space complexity, it would be, we're just storing these two, so, fuck, I always forget how to do space complexity. I think it's O of 1 because it's constant it's constant with respect to the input value. So I think it is O of 1. Double check that. Space complexity. Oh, fuck off. What? Dude, I can't even click it. Okay. What does space complexity mean? The term space complexity is misused for auxiliary space at many times. The following are the correct definitions of auxiliary space and space complexity. Auxiliary space is the extra space or temporary space used by an algorithm. The space complexity of an algorithm is the total space taken by the algorithm with respect to the input size. Space complexity includes both auxiliary space and space used by the input. For example, if we want to compare standard sorting algorithms on the basis of space, then auxiliary space would be a better criterion than space complexity. Merge sort uses O of n auxiliary space. Insertion sort and heap sort use O of 1. Space complexity of all these sorting algorithms is O of n though, because why? What? Space complexity of algorithms is total space taken by the algorithm with respect to the input size. So since the input size is n, it would always be O of n. Space complexity is a parallel concept to time complexity. If we need to create an array of size n, this would require O of n space. In recursive calls, stack space also counts. Okay. So, based on this definition, the auxiliary space would be O of 1, and the space complexity would be O of n. Does that make, dude, it feels wrong. Space, shit. It's supposed to fucking hell, bro. Sometimes this shit is so ass. Memory space required to solve an instance of the computational problem as a function of characteristics of the input. It is the memory required by an algorithm until it executes completely. This includes the memory space used by its inputs called the input space and any other auxiliary memory it uses during execution, which is the auxiliary space. What the hell? O of n to the alpha. What the heck? Okay, so yeah, the auxiliary space would be O of 1 because it's const, or O of 2. The memory, any other? O of 2, I guess, since I'm storing 2 extra variables. And then the space complexity would be O of n because I am just taking into account the input list because it's part of the parameters or whatever. Okay, well, that one was easy. Next one, valid palindrome. A phrase is a palindrome if, after converting all uppercase letters into lowercase letters and removing all non-alphanumeric characters, it reads the same forward and backwards. Alphanumeric characters include letters and numbers. Given a string S, return true if it's a palindrome or false otherwise. So input a man, a plant, a canal, Panama. A man, a plant, a canal, Panama. It's a palindrome. So they lowercase everything. They took out all non-alphanumeric characters, so the spaces, the commas, the colon, and then they just like did a palindrome check. Just think of that as a black box for now, and the check passed true, so it worked. Race a car, false. Input size, oh, what happens with it? So if an empty string, because it was only a space, empty string is a palindrome. Okay. So how would someone go about this? So the first thing that comes to my head is we got to get rid of all the non-alphanumeric characters. Get rid of all alphanumeric characters. I think there's a Python function to check if a character is non-alphanumeric or not. So, what could we? Okay. I'm like thinking of too many. I'm thinking of like what's the best way to do this? Let's think of one way to do this and improve on that first. So, get rid of all alphanumeric characters. We can do this with for loop. Oh, I just write the time complexity so far so I don't forget. I'll have to deal with thinking about it later. Okay, so once we have that, we have a string like this, right? So then we just have to, like one way we could do it is we could just like reverse the string. Make new string that's reversed and compare. And like that would be pretty easy. I think I also like solved this problem before because like I just like remembered how NeetCode did it, I think. So let me try to reason about it. Okay, so let me think about the solution first. So this would be O of n, making a new string that's reversed and compare. So what would that actually mean? That's like another O of n pass because like you gotta go through it again to know how to reverse it, right? And then if we're making a new string that's O of 2 and space complexity, because we're pretty much like doubling the input size. Like it's not exponential with regards to the input, but it's still like we're still using more, right? So it's like we could definitely improve on that. So I think the way NeetCode did it was he had 2 pointers. He had one at A, or one at the start, one at the end, and it was like check if they were I can like visualize what he did, but I can't put it into words. Let me try to draw that shit out. Let's search. This is an ampersand, by the way, and it's gonna be a space. That's a palindrome. Like he had, I guess it's like too easy of an example, but let's just say there's a period right here, and a period right here. So he would like put the pointer at the start, pointer at the end, because like the goal here is, like the problem with the solution is that we have to do 2 passes, right? So this is a way to do it in just 1 pass, which is 1 pass is better than 2 passes, right? And we also don't need you don't need to store another string. So that makes the space complexity better too. So we start at the start, no, pointer at the start, pointer at the end, and you just check, first you check if it's alphanumeric or not. So this one is alphanumeric, this one is alphanumeric, and then you would just check if it's the same. So it's the same, right? If it's not the same, you would immediately return false. Okay, you return a Boolean. So okay, these are both good. So let's go to the next letter and check if it's alphanumeric. And if it's not alphanumeric, what you do is you just move that pointer forward 1, because if it's not a number or a letter, you can just skip it, right? Like that doesn't matter. Oh, like fuck, I had an example. It's right. Period, right? Like okay, the period is not a number, it's not a letter, so we don't even care about it. So we can just skip it and then go to the R. Now it is a letter or a number, and the other pointer is also a letter or a number. So we check the equal and the R, so we can go to the next one. And you just keep doing that, right? And if you ever get to a point where it's like, okay, let's say there's L here after the O, right? Okay, so next, so we would come here, and we would go here. Oh my god, actually, stupid drawing. Okay, and we're at the L. This is pointing to the L, and then O and L do not match, so we just return false there. And we just keep going until the 2 pointers meet in the middle. And if they meet or they pass, then we know, okay, we've gone through the entire string without any errors, so we can just return true. So let me think about how to code that. So we would pointer at the start, pointer at the end, and what would we do? So what would be the condition for the loop? I think we would need a while loop, because we don't know exactly like how far it's going to go. Like, we just got to keep going until like they meet at the middle or cross, right? And I think the way that you meet at the middle or cross is that, so like pointer, like this would be the left pointer, and this would be the right pointer, right? And if at any point left becomes greater than or equal to right, then you would just like break out a loop, right? So we would something like while left is less than right. I think that would be the loop condition. And okay, so while that, now the part that's tripping me out is like I'm thinking, like this is like a synchronous program, but I'm thinking like, oh, it'd be happening at the same time, but that's just because I've been doing stuff that's not synchronous recently. Oh fuck, what would I do? Okay. The first thing we would check if it's alpha numeric, because now just skip forward, right? And if it is, and then what? Check it's alphanumeric, and then we would compare values, and then return false, or just keep going. Either return false or increment decrement pointers. I don't care if I spelled that right. Okay, so left is equal to 0, right is equal to length string minus 1. And while left is smaller than right, what would we do? We would check each one, right? So if s left, what's that? Python alpha numeric. Bro, what the fuck? Python alpha numeric function is al num. Check if all the characters in the text are alphanumeric. Oh. I mean, I guess like we could just do the whole thing. No, whatever. We'll just do this. If s dot left, if not s dot left at al num. Is it like a method? Yeah, it is like a method. Okay. If not s dot left at al num, left plus equals 1. If not s right al num, right plus equals 1. And then, okay, so I think these need to be while loops instead, because if there's like a bunch of non-alphanumeric characters, like it has to check, okay, next, until it gets to a letter and number, because then we can compare, right? So I gotta change that up. And okay, so at this point, okay, we check the left side, we're at a letter or a number. We check the right side, we're at a letter or a number. So if s left is not equal to s right, return false, and then we return true. Because if we go through the whole thing and it's past, meet or past, then okay, it is a palindrome. If at any point it's not, we return, okay, this looks right. Let me read through it one more time. Like double check. left is 0, start the array, right is end of the array. Iterate through. I'm not even reading, I'm just like skimming through. Fuck, let's just test it. Bruh. Is al none. I'm actually baka. Oh, I got debuggers. Is it debugger? Yes. Hope I didn't fuck up the. I was taking way too long. I think I fucked something up. Bruh. Okay. This is where the fun begins because I gotta debug it now. Okay. Is it because of the? No, it's not. It's actually just like broken. I was thinking, oh, maybe I clicked the debugger and that like fucked with the runtime. No. Okay. How do I debug this? Okay. So first, okay, what is al none actually return? Returns true if all the characters are alphanumeric. Okay. So, pointer at the start, pointer at the end. Okay. While left is less than right. I think this is right. While not s dot left. Okay, first, I change these to ifs. Like it should run, right? And if it does run, then that means my just condition is something wrong here. And if it doesn't run, that means like that my condition, like this is probably wrong. Okay, so this is probably, oh, because it's always, no, while left is, okay, no. This runs until left is greater than right. So that's probably fine. Fuck, I'm actually so stuck. How do I even like debug this? Not, okay, while left is less than right. No, not, that's not what that is. If I just do, nah, I was thinking like, okay, like fuck this, let me just do the stupid method instead. But no, I will figure this out. I will find out what I did wrong here. Like why, it's not, it's like it's taking too long. Why? I know this will like return true and like just like not pass, right? Yeah, okay. So, okay, I knew that was gonna happen. Like, why did I even do that? I guess just like for some like positive feedback to feel right. While left is less than right. Okay. Counter equals 0. Print counter. Print string left counter. I'm just trying to see. Maybe this will reveal some stuff. Counter plus equals 1. Will I even get any standard output? Okay. So it only printed these ones, so it never even went through these. Oh, is it because I didn't increment these ones? Also, like, you gotta subtract it. You don't add that. What the fuck? Minus equals 1. Silly. No. Okay. Well, this is an improvement. Okay, that's right. It's original. Okay. What happens if you call? I think lowercase it Python lowercase function dot lower. What happens if you do that on a Python 3 center? S equals 1, 2, 3. Print s dot lower. Okay, so that should be fine. Lower. Okay. String index out of range. Okay. What is the? Oh, because okay, it's not just like if you go here, like you gotta make sure it's still in bounds, huh? Okay. So this is the case where there's only 2 non-alphanumeric numbers. So it goes here. Okay, go next one here. Okay, go next one. How many did I pass? I'll pass 7. Fuck. Okay, that's actually like so ass. And left less than right. And right less than left. I don't think this is gonna work, but this is just like a shot in the dark. Yeah. Am I tripping? Okay, I'm not tripping. That's old. But, okay, I'm like, So what is happening here? Let me just do that real quick. See what's happening. Okay. It's actually like terrible logs. All right, okay, 0. Because it's comparing A. Okay, 1. Space. It's left 1. Skip it. I'm saying left 4 twice here. Strange. Left 1. Okay, go to the next one. It's 2. 1, 2, man. Okay, we compare it, go next. A. Compare it, go next. 4. Okay, here, left 4. Left 4. Left 4. Left 4. So we're at A now. And here, okay, let me add mine. Okay, A. 0. M. 1. A. 2. N. 3. And then 4. Left 4. Left 4. A. Am I tripping? Like, why? Okay, so it's worked without this check. Right? Like this test case passed without it. Okay, so these conditions are wrong. I think it's a fair assumption, so while and left assistant right. That's great. Maybe. Okay. Awesome. And okay, so the runtime with this is still open, even though there's like a couple nested loops. It's because it's still like one pass through the input, right? Oh, is it because I'm printing? If I move all the prints, will it get better? I know this is like pretty dependent on like your system. Okay, nice. But it still feels good to see like a high number. Okay. That one was harder. I haven't done LeetCodes in like 2 months, which is like still a little copy. Because like, okay, this is like an easy ass problem, but still. Okay, let me. So my debugging strategy was helpful because I was able to see what iteration we were on, right? So like that was a positive, but I think I could have made my life easier if I just included like more information in like the debugging logs. Like if I, if in these, right, like this one, I could have put like, okay, like before print, total iteration number or something like that, right? And then space this number, and then here, right? If I should have put like print left, which I did, the number, which is fine, but I think I should have included the letter left was on as well, so I can see like, okay, it's the same thing here. If I put like what letter right was on, and I put what, just like what letter it was on, because the counter was helpful, right? But it was still like kind of annoying having to like match. Okay, where was this exactly, right? If I had that little bit more information, I probably would have like figured it out a little faster. But like that was still like, I think that was a good way to debug it, to go through each iteration and see like what was wrong. And if I look and knew how to use a debugger, I could have probably just set like a breakpoint here and just step through it. I should learn how to use a debugger. Anyways, okay, next problem, last problem. Let me check my phone real quick. Break time. I have to text my girlfriend. Okay, valid parentheses. Like the first one, the stock problem, like I did before, it was like, that one was like the easiest one, obviously. And let me stop talking stuff, bro. Given an string S containing just the characters, open parentheses, open bracket, close bracket, open bracket, close bracket, determine if the input string is valid. Then input string is valid if open brackets must be closed by the same type of brackets. Open brackets must be closed in the correct order. Every closed bracket has a corresponding open bracket of the same type. So, okay, this one, that's true because open, close. This is true because open, close, open, close, open, close. It's false because we open and close with different ones. This is, okay, so that makes it kind of interesting. So we open one, we open another one, and we close that one, and we close the first one. And then this one is wrong because we open one, and you can't close an open one of different types. Okay, so I've done this before. Or like I know enough about the problem that like, okay, we use stacks here because a stack is a last in, first out data structure. So okay, here last in, it matches, here matches. Okay, so this one, right? okay, we push this one, right? And then we push this one, and then, okay, it's a closing type, right? So we go, oh shoot, we pop the last one off the stack, and then it matches, and then we're good, right? And then we go to the next one, and we pop the last one off the stack, and then we're good. So we need a way to determine if it's a open, closed type, because if it's an open type, we put it in our stack, right? If it's a closed type, we pop it and we compare it to what we have, because yeah, that makes sense. We need a stack to store open types, and then we just go through string linearly, and if open, push to stack, if closed, pop stack and compare to close. Where's if same type, continue, if different, return false, outside of loop, return true. Okay, so one thing, okay, where did I go wrong last problem? I went wrong because the logic for my conditionals and the inner while loops were just like wrong. They were just like stupid. So that was just like, I was like so comfortable with the code that I was like so sure it was right. And then I wasn't able to like kind of detach myself from my own code and kind of like see where the issues would be, right? So I guess like I gotta like read, okay, if something goes wrong, like proofread your code and like critically and actually like make sure it makes sense. I should do that if like my initial solution goes wrong. Okay, are there any edge cases for this? What if it's an empty string? That's like an easy edge case. It's an empty string, it would just be true, right? Because like because it doesn't make, like, none of these become false because there's nothing in the string, right? So like none of these can even become false, so we're good. Is this shit on? Oh, no, it's not. Okay. What else? Empty string, no string. No, it's not an edge case. Better. Okay. Determine if it's okay. Need a way to determine if it's an open or closed type. I think. We can use a hash map for this, because we just like check, right? Like we have the hash map would only have 3 values, either all open types or all closed types, right? And then when we get to something, say this, right? We check it. Is it in the hash map? And say the hash map consists of all open types. So we're like, oh, okay, it is in the open type. Let's put it in and check, right? And another useful thing with the hash map would be that it would make like checking if it's the same type like easier, because say, okay, like we're at a closed one, right? We're at this one, right? Like, okay, it's closed. So we could pop the stack and get this one, right? And we could use this hash map because like one of these would be the key, right? And the value would be okay, I didn't specify that before. The keys of the hash map would be one type, and then the values would be the other type. So either be open closed or closed open. I don't know that my hand symbols were right there, but I think my point is made. So yeah, okay. So we would just use a hash map for this, and okay, use hash map table. What's the difference? I'll figure that out later. We need a stack to store open types. Use it. How to use stack in Python. Oh, the fuck? Is it Siri knowledge? Oh fuck. No. I have Siri on my phone opened. Stack linear last name first. Okay, I was right. Or first name last name. Philo, LIFO. The list. Append. Okay, so just append, push, pop to pop. Then pop it, that give you the value. Okay. Okay, so table. No, table's a bad name. It's a good name. Matching table. Slightly better name. Okay, what should I make? It doesn't really matter. What will make it coding easier in the future? Would it be have open? It doesn't really matter. It either makes like the initial check easier or the later pop easier. So it doesn't really matter. So if it does, I can just change it, right? Is this? No, I'm just not gonna deal with that. Where's this? Oh. Close. Okay. Is this syntactically correct? That looks right. Okay. Stack is equal to that, and go through the string linearly for character in S. And then wait, okay, I just thought of something. So what if we start with a closing, and then we end with another closing or an opening, right? If we start with this, and we go there, like that's wrong, right? Because open brackets must be closed. Every closed bracket has a corresponding open bracket. So Yeah, that's wrong. So I think the easiest way to check that is just like outside of the loop, just check if it's if there's still stuff in the list. So if it's not empty, check if not empty outside of loop. Check if not empty outside of loop. For character in S, if character in matching table stack.append character else. So if it's not in the matching table, that means it's a closing bracket. Else if matching table stack.pop not equal to character, turn false. Because okay, if it's not an open type, it's a closed type. So if we is it pop okay, that would be an attribute, not a method. So okay, we pop the last opening type, right? Because we're only pushing opening types, and if the last opening type is not, they don't match, right? So we would just return false, and then we would just keep going. And outside of here, if length stack is greater than 0, return false, return true. Okay, let's check. Accepted. Show it. Bro, pop from empty list. Okay. So what's happening is, since it's a closing bracket, okay, so it's a closing bracket and there's nothing in the stack, right? So we gotta also check if the stack is empty. If when stack is less than 0 or, right? Because if the stack's empty and there's something to check, like, okay, there's a mismatch there. Bro. So it's still calling it? Dude, what the fuck? Like, so I guess this needs to go first. Let me read there first. Just listen. Okay. What the heck? Let this turn false. Else if turn false. Right, because this, check this first. And then, okay, if we're good here, then we can check this. So this should prevent this. I think. What? Syntax error expected : else if matching table select. I forgot. Still popping from an empty list. So that means this check isn't working. Oh, less than or equal to 0. Awesome. That's freaking awesome, dude. Okay. Nice. What would be the runtime? The runtime would just be O of n. Because we go through the whole input once. The space complexity would be O of n, because we take into account the input string, and we save it sometimes. The auxiliary space, oh, that's kind of tricky. It would be whatever the size of this is, plus like the size of this. So the size of this would be like however many open brackets. It would be the number of open brackets in a string. And that would be the upper bound to this, because if there's like a closing bracket before, it would just be just the number of open brackets. And this would just be whatever this is to get the size. I'm kind of curious on how to get the size of a Python dictionary. Anyway. This much on process. Oh, that's interesting. I did not know you could do that. Now, this only measures the immediate memory usage of the dictionary object. It does not recursively account for the memory used by its keys and values. Pi and blur. What is that? No, it's just memory. Looking at memory. Okay. So 3 problems done. I'm probably gonna do this assessment now off video. Thank you.